Okay. So thank you very much for this opportunity once again. As she said, my name is Clement. I'm currently at Imperial College as a clinical trial statistician after my postdoctorate in Oxford. I'm happy and very humbled to also learn something on R-programming. Some are beginners, and some are also maybe advanced users of R. So I just hope that I could get this intersection, and then at the end of the day, I believe everyone, irrespective of your level, you pick at least something new. So without wasting much time, I would quickly share my screen. Okay, so without wasting time, I will quickly just take us through the program outline for today, what I aim to cover and so on. So everything you are going to see, you don't need to memorize anything or try to necessarily jot something down, because you all have access to these. So basically, I've already started, or I have a YouTube channel where I started this online programming school on R programming, specifically for advanced data analysis. So it's something that I started about close to 2 years ago, though I've not had much time to really advertise it much. So it means that I've covered almost everything you really need to know as a beginner, installing packages, and also even doing data analysis, creating functions. There are a lot of stuff that we are uploaded there. So just a quick one before we start the program. So it means that there are already 16 videos uploaded there. And most of the time, any program that I do, I try as much as possible to also upload the videos also there for people to also learn at their own pace. So it means this particular session, I will speed up a bit. Nonetheless, it means you can actually go back and watch these videos at your own pace, and then you'll be fine. So it means that there are already about 16 videos. So, and then I've named them. So it means the first video, you could see there's first, how do you call it? Just a minute. Okay, so you could see that here we have the first lesson, we have the second lesson. So it's numbered in that fashion. And then you can see things about maybe the most important information you need to know in statistics, switching from RStudio to Jupyter Notebook, so many things, regression, and so on and so forth. So it means that this particular session, I'll try and tackle it from a different perspective so that I don't repeat myself. So this is to say that most of the things we are going to learn, you could actually start from scratch from the YouTube channel. And then I'll also upload today's session also on the channel, so you could learn from there as well. And then on the YouTube channel, all the scripts, the data, everything that I use for the lesson, I have a particular platform called Piazza. So this Piazza is a platform that I use to manage the class, such that if you click on, let's say, the resources bit, meaning that if you click on this particular link here, you'll be able to see everything in terms of all the codes, the data that I've been using for the class. You can easily just click to download. So this means that everything that you see in this course as well, all the materials will be uploaded on Piazza. The link will be made available so that you can easily download not just this, but all the YouTube channels, the YouTube videos I've done. You could have access to all the materials so you can practice at your own pace and so on. So I think that is quite useful, and I hope you learn from it as well. And don't forget to subscribe if you can. All right, so today's program outline is quite interesting. So I'm trying to approach it from a different perspective. So the first thing is we are going to just touch a bit on R, what is R about, and what are integrated development environment. So we'll touch a bit on some of them. And then I'll give a brief introduction to data analysis. This is to say that to use a particular statistical software, it is imperative to understand how you could go about the analysis, by understanding the data structures we have there, understand the kind of variables and how they would influence and your choice of models and so on and so forth. So it means it's imperative for us to touch a bit on that. So that is not necessarily programming, but it's just a quick overview. And then the next one, we are going to learn on how to import and export different data structures. So it's possible you could be an SPSS user. You've never used R. You have data in SPSS. You have data in SAS. You have data in Stata. And you want to be able to still do all the analysis in R. Then, so in that case, we are going to learn how you can import data. There are instances, maybe you have data in SAS, but at the end of the day, you want to convert the data into CSV or into Excel. It means you can actually import a SAS data into R and export it as an Excel or any other format of interest. So these are some of the advantages of also using R. And then the fourth one, which is very interesting, which today I believe so many people really, really appreciate it, is how to use ChatGPT with programming. So you find out that is extremely useful. And today I would demonstrate to us that if you really want to improve your programming, not just your programming, any analysis you are doing, irrespective of the programming software, you could be a Fortran user, a C+ user, or you are new to a certain programming language, you have codes in R and you want to be able to translate the codes into, let's say, Python, or you want to know how you would do something in Python or something in R. ChatGPT would easily do that for you. So I know that there had been this debate, especially from those in the social sciences, trying to argue that sometimes ChatGPT does not actually provide them with the most accurate information when necessary. It's not. I'm not into social science, so I can't necessarily argue with that. But as far as programming is concerned, it is over 99% really useful that you could clearly see as time goes by. So it's something that I think everyone should watch out for that. And we are going to touch a bit on that. And then the next thing, you are going to focus on some advanced data analysis. So on the YouTube channel, once you start, the videos from scratch, you realize so many complex data visualization that we've already done in previous sessions and even last year's class and so on. And I don't want to repeat myself. So today, the focus is to introduce something called slope graphs, because there are instances where you have a pair data. Like, what I mean by pair data, there are instances where you've collected data at a certain time point, and you have also collected the same data at a certain future time point, and you want to be able to explore the change and visualize the change whilst capturing individual heterogeneity in the data. So this is also something that we are really going to explore. And at the end of it's one of my favorite graphs, actually. So I want other people to also be able to use. So in the practice tasks, you'll be able to do more complex slope graph and so on. And due to time, I couldn't touch more on the mixed effect models and panel regression. I think I'll do probably a separate YouTube video for that as well. So without wasting time, now let's start the first bullet point. So now we are just going to talk a bit about what R is about, in terms of the IDEs and how to run R. Okay, so now I don't know how many people who have really learned about programming, but when we say programming, different disciplines would have different, interpretation and even explanation to what programming is about. So those in computer science, how they would understand programming and how they use it would vary from other disciplines. Specifically, a mathematician would talk about programming in the context of modeling, or would talk about programming in the context of maybe doing some numerical analysis or solving a certain statistical problem, and so on and so forth. But someone from computer science will be talking about programming by using it to maybe develop an application, or probably developing an application, for instance, just that there are always intersections across different disciplines. So here we are talking about statistical programming or mathematical programming. And then by programming in this case, the emphasis is that we want to be able to do data analysis. Now, I'm sure most of you have already installed the R software, and if not, these are the steps you could use to install the software. So basically, if you click on this link, you find out the steps. So I've given you the steps. The first thing is to install the R base or the base R, and then you just go through this document. You'll be able to install it successfully. So I wouldn't go into the installation because I've already done videos on that as well, but this is just a quick link to installing. But remember, if you are a Linux or Mac user, you don't need to install the R tools. So R tools is only for those using Windows operating system. So the first thing is you install the R base, and after installing the R base, you install something called the R Studio, and then after installing the R Studio for Windows users, then you go ahead and install the R tools. But for those using Mac and then Linux operating system, you don't need to use or install R-tools. Okay, so now let me just quickly share a different screen. Yeah, so where's the, just a minute. Okay. So now if you have installed R, so there are two. So initially I was talking about integrated development environment. So when you talk about IDEs, when you abbreviate it, when you talk about IDEs, they are basically every programming language. Okay, every programming language needs a platform to run the language or to run the software. So IDEs are basically like platforms within which you can run a programming language. So in R, the base R looks like this. So this is the base R. So in terms of the base R, this is how it looks like when you open it for the first time. And of course, if you want to write script, you can click on new script, and then you do all sort of statistical stuff in there. But I'll never recommend students to use the base R, especially if you're a beginner. And I really, even if you're advanced, I think using the R Studio would be much useful, because with that is a little bit user friendly, much more than this one. Because with this, once you produce a graph, it opens on a different panel, and it doesn't automate your code such that if you try to, let's say you want to find a mean, you start typing the mean, it won't pop up. But in the R Studio, those things comes naturally. So I wouldn't recommend that, but that's the first IDE for R. So we call it the base R. So this is the R Studio. So in terms of the R Studio, I was doing a couple of things here. So so first of all, when you install the R Studio, there are instances. I wanted to use a different. Okay, fine. So there are instances, maybe you've used your software, and then all these things pop up at the global environment. So the R Studio has, basically 3 views. So the first view is, this is what we call the console. So console, people can directly type functions under the console. You can actually use R as a calculator. So it means you can multiply big numbers, do whatever you want to do, and so on. So this is what we call the console. But anything you type under the console, once you close R, all those script or codes would vanish, meaning that you will lose everything. So that is why it's always good to create a script. So to create a script, you click on File, and then you click on New, and then File. I've already touched all about on these things on the YouTube channel, so don't worry. Don't try to understand everything now. I just want us to get a fair idea. So this is more like an overview, and then you can now take your time and go through the videos, and you'll be fine. So this is what we mean by how a script. So it means you can now type any code you are interested in here. Now keep in mind that anything you run. So for instance, if I create a certain vector here, so let's say 1, 3, 4, 5. Now, the moment I run this, I just click on, I run this, it pops up here. Now, so it means any data you import, any variable you create. So this X1 is called an object. Then what we mean by an object is that you want to be able to assign any code, it could be a data if imported, to a certain object, so that at any point in time, if I want to call that particular object, all I need to do is I can now use it. I can even multiply with something, and then we are good to go. Fine. So it's always imperative to always create object or assign objects to any particular function you're working with. Fine. So these variables are the global environment. You can just delete them if you are not if they are not useful. So all you need to do is you just type rm list equals ls that, and then it clears that from there. These are not necessary. I'm just trying to let you know that you can actually clear all those data or variables that you don't need that are at the global environment. Fine. Now now let's just do a simple visualization. So let's say I'm simulating data, let's say from a normal distribution with this sample size of over, let's say 10,000 or 100,000, and let me create another one, a similar one. Just a minute. And then afterwards, we want to do some simple plots, and then I want a blue color in this case. So I just want to show you, when you do a plot, where does it appear on RStudio? We are not going to use RStudio for this particular session. It's just for us to have a fair idea when you have to plot something, where does it go? All right, so this one, I just simulated like about 100,000 data from R, and I'm trying to plot them. Okay, fine. So now it means anytime you plot a graph, this is where it pops up, and you can actually click on zoom, and it will zoom it, and then you can actually export it as a PDF, save it, and do anything you really want to do with it, and so on. Fine. So basically, RStudio is user friendly such that if I want to, let's say, find the mean, the moment I start typing the mean, you realize that it pops up. So it means you can now find the mean of a data, and so on and so forth. So this is just what I just wanted us to have a fair idea. And in RStudio, you can import any data structure. So suppose I have a data in SPSS, and I want to import that data. All I need to do is I click on SPSS here. So remember, you just go to this bit where we have the import data set. You click on it. You click on, let's say, SPSS. If it is SAS, if it is data you want to import in R, without using a command line, all you need to do is, so if it is SPSS, I just have to click on, let's say I want to import it, let's say SAS data. And then there's a browse option here. Then you click on the browse option, and then you go to the folder you are interested in, meaning that where you have saved the data. We'll talk about working directory very soon. And then, yeah, please, can we see the data view at the moment? Can someone unmute, and can you see the data view?
Yes,
Hello.
please.
All right, so, and then all you need to do is to now click import. So this is how easy you can actually import any data into R without necessarily using even a code when you are using RStudio. So it means you just go to import, you specify if it is a test data, if it is an Excel data, SPSS data. All you need to do is you can do it manually by just clicking on, if it's SPSS, you click on that, then you click browse, you go to the folder of interest, and then you click on import, and you're good to go. And then you have the data in there. Now so that's how easy you can have a data in R, and so on and so forth. Fine. So at the moment, we are just going to go to the other IDE I was using. So this is just a fair idea about RStudio, just to know the view and how easy you can maneuver your way around. And the next important thing is installing packages. So it means in RStudio, installing packages is quite easy. So you click on package here, you click install. What are packages? There are certain functions that people have written, such that maybe you want to do regression, and there's a package to do, let's say, generalized linear maze models, and you want to fit a generalized linear maze model. And in order to do that, someone has already written a function to do that and has wrapped it up in a package form. So what it means is that once you load that package, so let's say if the package is LME4, you realize that in RStudio, the moment you start typing, it pops up. And so you just search any package of interest, then you click install, and then the package loads. But keep in mind, you need an internet in order to install a package. So packages are useful, especially when you want to use a function, a customized function of for a particular analysis. So in that case, you'll be able to know which packages you need to install, and you understand all those very soon. So here you just click install, and then it starts the installation process. You see it at the at the console session. So here is where you are writing your script. Once you run a plot, you see it here, and then, but always don't type your code directly within the console session. Always create a script for that, and you can easily save your script using the normal save as, and then you specify a particular folder of interest, and you save your script. Fine. All these things I've already covered them in depth. So now I'll now go to the main purpose of today's session. So that is just a brief overview about the R Studio. So the R Studio is one of the IDEs for running R, and then the R base is also another RDE. Now this particular IDE that I'm using at the moment, as you can see, is called Jupyter Notebook. As you can clearly see, apart from the fact that I can use it to run R, if I should come here, you realize that the Jupyter Notebook, you can see Python in here. So it means that with the Jupyter Notebook, it can run 30 different programming languages at a time, such that it means I can actually open a new script for just Python, and at the moment I have one for R. So it means that this is like a Python script that I want to create. Fine, though I don't need Python today. But what I'm trying to imply is that with the Jupyter Notebook, what that means is that with that you can run multiple languages at a time, different jobs at the same time, and it's quite user friendly. And afterwards, it means that with that you can also use it for presentation. As you can clearly see, everything I'm going to teach today, in terms of even adding slides to the presentation, everything was done in the Jupyter Notebook. So it means it's really multi-purpose IDE, and I would always prefer that to the R Studio. And the reason is that with this, suppose you are doing your PhD, or if not PhD, you are doing a certain work, you do data analysis, or you want to share your results or show your results to your supervisors or to other people. It means that with the help of this IDE, that is Jupyter Notebook, you can actually, have your results, your graphs, everything will be in the same page, and then you can easily share with other people. All the codes will also be there, and the beauty is that afterwards you can even download the file as either R code. If I download it as R, it means that it will come as if you created the course in R Studio, or you created a course in R-Base, and then I can download it as LaTeX. It means that with that, it can create a PDF of all so everything you are seeing, it can create a PDF version of it for me. You can download it as a Markdown, you can download it as a notebook, so there are different options here, as you can clearly see. So there's a whole YouTube video on how to switch from R Studio to Jupyter Notebook. So without wasting time, in terms of the statistical softwares, so there are several statistical softwares or softwares you can use for statistics. Now, when we talk about programming languages, it's R, Python, Julia, SAS, C+, and MATLAB. These are some of the programming languages. And keep in mind that SPSS, Stata, eViews, Minitab, and the rest, they are not programming languages, though you can write a code in there, but they are just statistical softwares. When we say something is a language, it means that it doesn't depend on other languages to create its own functions, right? So when you look at SPSS, for instance, underneath SPSS are JavaScript and the rest, right? So when you talk about a programming language, it means that it's just a software, but it's a software that has set of codes. And those codes are what we are trying to say a language. So it means once you want to communicate with the software, it means you have to understand the set of code, that is syntaxes, that you need to use to communicate with the software. So these are just a few examples of statistical softwares you can use for any statistics you want to do. Now, I'm sure we already know what statistics is about. So in here, the focus is that maybe you started a study, you've collected data. After collecting data, you want to analyze the data, make inference, and even inform management decisions and so on and so forth. So, and there are varying fields in statistics. So it means operational research is another branch of statistics. We have econometrics, those who are into regression, time series analysis. Operational research is mostly into optimization problems, inventory controls, and many other things, but it's an intersection between statistics and mathematics, and they do a lot of application of statistics. So it means if you want to do a PhD, and then your focus is that you want to be able to apply your PhD, you want your PhD to be more of an applied statistics, operational research is one avenue you can explore. They also specializes a lot in game theory and so on and so forth. Now, biostatistics, I'm sure most of you are aware. So it means that it's this branch of statistics where we apply statistics to health. Okay, so it means that to medical data and so on and so forth. I'm sure data science too, we've heard about data science. So data science is also another branch of statistics, but their focus is that they are more interested in using much more robust statistical methods such as machine learning, deep learning, to investigate much more into data. And then, yeah, so that's basically just a few branches of statistics. Now, in any statistical analysis you are doing, if it's a research, we always split it or stratify it into two versions. So we have the descriptive summaries and the inferential statistics. So what we mean by descriptive summary is basically just obtaining some summaries with respect to percentages, mean, standard deviations, and those things, just to summarize your data numerically. And inferential statistics is where your goal is to now test some hypotheses, fit some models to answer some research questions, and so on and so forth. Keep in mind, you can never make inference or conclusions based on descriptive statistics. If you want to make any inference, you have to now do a proper test. So it means, let's say I want to test whether my data is normally distributed. Of course, we have plots or visual ways of achieving that. Now, if we do that visually, and then you want to conclude that your data is normally distributed, we are saying that is statistically wrong. You have to do a proper test, such as, let's say, Shapiro's test, or you want to do maybe Shapiro's different tests like ketosis test and so on, to conclude whether your data is indeed normally distributed or not. So the take-home message from there is that until you do an inferential test, you cannot make a more informed decision about, let's say, some research question or some hypothesis you want to investigate. Now, there are a few terminologies that we mostly come across when you are doing statistics. So you hear things about parameters, you hear something about a statistic, type of variables, scale of measurement, and so on and so forth. Now, when you talk about parameters, it's any metric or quantity that we compute from a population. So it means, let's say, we have a data on maybe we have a data, and the focus is that we want to know, let's say, the average age of Ghanaians or the average age of people in a certain population. Okay, so it means that those statistic, or let's say any quantity we compute based on the population, is what is called parameters. Now, when you obtain a subset of that population and we compute the same set of quantities on that subset, we call those quantities as statistics. All right, so that's basically something we have to note. Now, keep in mind that in order to identify a type of inferential test you want to do, let's say you want to do some hypothesis testing, you want to fit a model, the most important thing you need to note is that you have to understand the type of variables and also the type of data structures out there. The reason is because the data structure can completely inform the kind of statistical analysis you can do. And then keep in mind that all statistical tests, even including, so when we say statistical test, we are talking about trying to test an hypothesis. And when you talk about statistical models, for statistical models, sometimes people confuse what is a statistical model with a statistical test. So if you look at, let's say, a chi-square test, you realize that a chi-square test is trying to check whether there's any association between two categorical variables. At the end of the day, it's not estimating a quantity, it's just testing some hypothesis. But when you talk about a model, with models, there are always parameters that needs to be estimated. So when you hear things about regression, we don't say regression test. We say regression model because it's a function which has some unknown parameters that we need to fit or estimate based on data. But when you talk about statistical tests, we are not fitting the model to a particular data. We are just trying to test some hypothesis. So know the difference. And for either a test or a model, we have two versions. So we have parametric test and we have non-parametric test. For parametric test, mostly it must satisfy some parametric assumptions, especially normality. So let's say you want to do regression, or you want to do, let's say, a t-test. If your data is normally distributed, then you can use a parametric t-test. If your data is not normally distributed, then comparing the means is wrong. The reason is because means is affected by outliers, whereas medians are unaffected by outliers. So it means that for most at times, non-parametric methods explore the medians rather than exploring the means. And most of the parametric methods explore means and so on. And so here, I've already touched more on these things in the previous YouTube video, so I wouldn't go much into that. But basically, every data set, we could have quantitative data set, we could have qualitative data set. So it means anytime you have a data or a variable that is naturally numeric, then it means that variable is a quantitative data set. But here there's a disclaimer. If, let's say, there's a variable called sex or gender, and then in your data it has been labeled as 1, 2. The mere fact that it has been labeled as 1, 2, you know that is a dummy variable. Someone could have chosen to label it as 0, 1. So it means naturally the variable called gender does not take specific values called 0, 1 or 1, 2. Someone could even say 5, 7 and define 7 to be male, 5 to be female, and it will still work. So what I'm trying to imply is that assigning numerical values to a qualitative data does not make it quantitative. So this is something we have to be very careful about. When you say something is quantitative, when you use example age, if I ask you your age, you give me a numeric value. So it means any variable that naturally takes up numbers is a numerical data. That's what we mean by quantitative. But assigning a dummy variable or a dummy number to a certain data and qualitative data does not convert it to numeric. So let's keep that in mind. And so these are just a few statistical